Hello, and welcome to this Introduction to FORTÉ video. In this video, I will provide you an overview of the major components of FORTÉ, and will also provide an overview of the FORTÉ user interface used to set up CFD simulations. In the upper right hand corner, I have the FORTÉ launcher. The FORTÉ launcher allows you to launch the different components of FORTÉ. FORTÉ Simulate is used to set up the conditions for our simulation. FORTÉ Monitor is used to monitor the progress of cases that are currently running. And FORTÉ Visualize allows you to post-process and visualize the results once the simulations are complete. Let's take a look at the FORTÉ Simulate interface. In the middle we have the graphics area. On the left-hand side we have the workflow tree where the user works from top to bottom to specify the conditions for their simulation. The bottom left-hand panel is the input panel where you will specify the conditions for boundary conditions, conditions for spray model, spark model, and so forth. The window where my mouse is now is the FORTÉ tooltip window. If you hover over a label within the user interface, FORTÉ will populate this window with a tooltip identifying what types of inputs are expected from the user. The bottom right hand is a log window to let you know of any missed settings during the setup. On the right hand side is the visualization tree, which allows you to turn on and turn off the visibility of different objects within the graphics area. Along the top you have the file menu, edit, view, and utility menus. You also have a toolbar which provides shortcuts to certain operations like specifying profiles, compositions, parameter studies, and other inputs. Let's take a look at the workflow tree and how we would work through the workflow tree to set up a simulation in FORTÉ. The first step is importing the geometry. FORTÉ accepts STL files as input for geometry. The files can contain multiple surfaces or a single surface, and then we could split the surfaces as needed to identify our boundaries. In this case, we've identified all of our different boundaries. Now let's move to mesh controls. FORTÉ uses automatic mesh generation, so there's very little input from the user for mesh generation. The only required input is the location of the material point. I will scroll in. I did not mention before, but left mouse is rotate, right mouse is pan, and middle mouse is scroll or zoom. The material point identifies where FORTÉ should generate the mesh. In engine simulations, this is typically up in the head region near the head. And this point should always be inside the geometry during the entire cycle. The only required input for mesh generation in FORTÉ is the global mesh size. This would be the mesh size used everywhere in the domain. Typically, we need to add refinements to different parts or different regions so that we can resolve the geometry or resolve a specific region during an event, such as injection or combustion. Let's take a look at the models now. FORTÉ allows users to use very detailed chemistry very efficiently for accurate combustion simulations and prediction of emissions. In FORTÉ, you can import the chemistry set on the chemistry tab. Now let's take a look at the models. There are several different types of models within FORTÉ depending on the type of simulation you're trying to run. In all cases, we need to specify the chemistry or combustion model to be used for the simulation. There are several mechanisms included with FORTÉ, such as gasoline and diesel mechanisms. Now let's take a look at the models in FORTÉ. There are several different types of models within FORTÉ. Depending on the type of simulation you're trying to run, this will determine what types of models you will need to activate. If we wish to run a direct injected engine, we would need to activate the spray model. If it is an SI engine, we would need to activate the spark model. In this case, this is a GDI spark ignited engine, so we've activated both the spray model and the spark ignition model. There are additional models for modeling the crevice and modeling soot. Now let's look at the boundary condition. Each boundary within the geometry needs a boundary condition. This is where we would specify the inlets, outlets, and any moving boundaries within FORTÉ. For inlets, we would need to specify the pressure, temperature, and composition coming in through the inlet. Since this is an engine simulation, we would need to specify the piston motion. In this case, we specified all of the piston motion inputs for the stroke, connecting rod length, and RPM. In addition, we would need to specify the intake valve lifts and the exhaust valve lifts. In this case, we can look at our lift profile. We also need to specify the lift profiles for our valves. Let's look at an intake valve as an example. In this case, we have created a lift profile. If we click the pencil button, we can edit and look at the profile. You can see here, this is the lift profile for the intake valve. All lift profiles in FORTÉ should go from 0 to 720 crank angle degrees. Now let's look at the initial conditions. We need to identify and specify the different regions in the geometry so that we can specify the initial pressure, initial temperature, and initial composition in the different regions. In this case, we have an intake port region, an exhaust port, and the default initialization, which is the cylinder. For simulation controls, this is where we specify the initial crank angle and final simulation crank angle. In addition, this is where we would specify our time step settings, chemistry solver settings. Now let's look at the simulation controls. This is where we would specify the initial crank angle and the final crank angle for the simulation, if it is an engine simulation, or if it's a non-engine simulation, we would specify the end time. In addition, this is where we can specify options for the chemistry solver. If I collapse these, we can see we have controls over when we would like to activate chemistry. We can have chemistry always on, we can turn chemistry off if this is just a gas exchange simulation, or we can conditionally turn on chemistry during important events such as injection or spark. The user also has full control over the outputs from FORTÉ. You have access to spatially resolved data, which is data that's written for the entire domain, and you also have access to spatially averaged data, which is averaged over the domain. In all cases, the user can control specific crank angles where they would like to write out the data, in addition to specifying a frequency for the output. Preview simulation allows you to preview the motion of the different parts of the engine to be sure you've set up the boundary conditions properly. So let's play an example here. Preview simulation allows you to preview the boundary motion before you actually submit the run. This is very helpful since you can double check to be sure you've specified your lift profiles correctly and the piston motion correctly. Let's preview the motion of this engine. Looks like the motion is specified correctly. In addition, you can also generate preview meshes so that you can view the mesh before submitting the job to the solver. You can specify a crank angle and a location where you would like to view the mesh. This is very helpful since you can visualize the mesh and check to be sure the mesh is properly refined for the simulation. The last step in FORTÉ is to run the simulation. As you can see, here we've set up a parameter study for our spark timing. We can either choose to use a restart to restart the case, or we can run the case from scratch. You have options for running the job on the local machine, or you can prepare the job and move it to a remote machine to run. Thank you for viewing this introduction to FORTÉ video. If you have any questions, please feel free to contact ANSYS Reaction Design at reactiondesign-info@ansys.com. Thank you.